enum tutorial. This is one of my favorite features about Rust is their enums, because they're not just regular enums. You can stick all sorts of things inside them. And I'm going to show you an example of that. What I built sometime in before. Hey, check this out. And the autocomplete automatically completed it. It auto-completed it. That is really neat. That is really neat. Okay. So vi source main. Let's see. So this is simple hello world. Let's see if we can cd rust. What was it? /rust hyphen ggg, please. Let's see here. Rust cache. There we go. Cargo run. Let's see. All right. So there we go. We got the hello world. At the hello world. Import JSON. Ooh, can we import JSON? Well, Zergio, today we're doing a little bit of Rust. And is it JSON? It's like Serde JSON, right? Is that the most common used JSON library in Rust? Serde JSON. We're going to do something really simple. Vi source main. We're going to create a Tokio, what do you call it? A Tokio-based multi-threaded cache. So that way you can have all your cache stored in one thread and you can share that memory across all the other threads efficiently. That's what we're going to do today. Tokio async. This is going to be multi-producer, single consumer, and a one-shot. There we go. These are the only libraries we're going to import. It's going to be really easy. It's going to be really easy. I like this right here. MPSC, multi-producer, single consumer. It basically says you can have multiple threads, which you do with Tokio, and you can asynchronously and concurrently with concurrency safety, pass requests into a master thread, a main thread. And this main thread is going to hold all of our cached data. And so whenever one of your threads needs to access your cache, it can just call in. It can reference a one-shot, which is just a response channel. And it can fetch out data from a cache. It's really neat. It's really neat. Say Tokio plus crypto. Yep. Hey, Quantified Quantum, good to see you. Welcome on in. Good to have you here. The OpenClaw alternatives. Hey, Sigma Edits. Hello, everyone. Good to see you, Sigma. All right, Tokio main. And this tells the main loop, the main render loop or the main run loop is going to be here with Tokio. There's an event base. So with asynchronous programming, it's essentially a really neat pattern. It's really neat. The operating system, it's very expensive to call into the OS to make things happen. You might want to write a file. You might want to start a timer. You might want to do a lot of different things. And you might want to get IO on a network port. You might want to open a port. You might want to listen. There's just a lot of expensive operations. However, there is an event engine, right? You could call this like KQ, epoll, poll, that allows you to register on the operating system once using a file descriptor. And then you can just pass data in events to interrupt your user space application. And you'll get amazing performance. It's the best performance in the world. It's really great. And Tokio just makes that really easy. So this defines the event base, which is going to sort of loop forever. Essentially, it's like a loop forever. It's really neat. It's really neat. And so this turns this into a wait interrupt. This will interrupt and call into your system. It's pretty satisfying. I think it's really neat. So we're going to build this really quick to make sure it still builds. We're going to create an enum. Okay. Request, I think, right? And then we get to define, this is the enum. So we're defining an enum called request. This is really neat. We need to get, let's see here. Let's right to get, we need a set. We can have a delete. I think that would be a good option. Okay. Those three seem good. So we're going to have a request, and a get is going to require us. So in normal enums, it just looks like this, where you're setting things like this. You have a get, you have a set, and you have a delete, right? That looks like a normal enum. You would expect nothing else. However, then we need to implement a cache. So this is going to be a struct cache, and this cache specifically is going to, we're going to need a, what do I want to call this? JavaScript has taken over. Yeah, it's done. It's the one. It's a JavaScript now. I know. It was for a second. Don't worry, we're back to Rust now. We're back to Rust. So this is, it's not a request. It's more of a, it's more of an entry point. It's more like the address. So rec, I'm just going to call it rec for a request. Multi-producer, single consumer, and we're going to use a sender, and it needs a request, right? So it's going to be this enum. It requires an enum, like that. Boom. I believe this should build. All right, we're good. We're building. Always build. Every single time you type one line of code in Rust, you want to rebuild it, because if you don't, you'll regret it. We need to do one more thing with our cache initializer. We need to take the response and spawn a Tokio thread or a Tokio greenlet that can be used to capture we need a new request. And I believe we can just create a new request right here. A request enum. It's going to be a set, right? So we got a set, and we're going to create the strings right there. We need to do key.toString and value.toString. I think that'll do it. I think we have to await this though. So very clean and easy to understand. You're taking an MPSC, and this is going to be the requester, which is going to be one of the multiple processors, right? You can have multiple producers in a single consumer, right? We need to define the consumer here. We need to create a cache service. The cache service is going to create a new cache, I believe, and a hash map. Shouldn't we have a hash map here? Shouldn't the hash map be here, I think? We'll deal with that later. We'll try that later. We'll try it later. Okay. So we need an async function cache service, so we need a cache service that's going to receive a request, which I believe we have this up here, right? So this is the sender, and we need a request. So we need the opposite. We need the opposite. We need the receiver. So not this, not the sender, the receiver. Receiver, R-E-C-E-I-V-E-R, request, right? Okay, I think that's good. Maybe a little bit of a big deal. We should pay attention to it. Don't get me wrong. You're right, Bonzupi. Like, we shouldn't say, oh, nothing's happening here, nothing to worry about. So, a smidgen of attention, right? A smidgen of a big deal. All right, so we're going to get our hash map here. So this will be a hash map. This is where all the data is stored. All data is stored here inside the scope. And we're going to be creating a new loop to rescind on a receiver, which our receiver is going to be here. So this is a receiver. We need to match on exhaustive match. So this is the part where we have to exhaust on our set here. We got to exhaust on our set. Set. And key value. And I believe that's all we're going to need because we don't have anything else defined right at this point. So we're going to have a cache service here. It's about how you fall. Oh, is it? Is it? Okay. We've got a request, match. Okay, so what do we want to do inside of here? It's spinning the cups instead of the spoon. What does that mean? What does that even mean? I don't know. I don't know. You have depression and an IQ of 152, if that's what you mean, Bonzupi. Okay, so you're on the edge then. Yeah, you're on the edge of the ultimate super genius, right? You've got a high IQ, and the higher your IQ is, it is difficult to not be depressed. You make my learning fun. Oh, Zergio, well, thank you. Appreciate it. Yeah, that was really nice for you to send the $1.99. I appreciate it very much. All right, so we need to, so we're going to update, we're going to mutate our map here. Map.insert key comma value. I think that's all we got to do. And then this should build, or not. Okay, we got an error somewhere. Did we type that wrong? This doesn't make any sense right here. Oh, wait. Oh, right. We got to match the request. There we go. From all other threads, asynchronously in the Tokio runtime. We got our cache here, and we got to use it. We got to use the cache. Do we need to start the cache service in order for it to work. Okay. So now that we've got our cache service, we need to start it up here. So Tokio spawn. It's really easy to start a thread. It's really easy. Cache service and the res. The receiver. Let's call it receiver. There we go. This is the request. This is the receiver. All right, I think that should do that. That will start this as a thread. And it will wait on, back to our code, you guys. We're going to keep on going. We need to implement our getter here. Let's implement our getter. Okay, our get request. This is going to be, okay, we're not going to do to do because we're going to create a closure. We're creating closure here, and then we're going to read data. Map.get key. We're going to clone it so that way we can pass it up the chain. Send. This is the one shot right here. Reply one shot. Right, that's the reply one shot. Okay. I think that implemented it. Okay. Do request get, and our get needs to have this information. And I believe we're going to have our key and our one shot, which will be the reply. I think so. No, just the reply. Just the reply, please. Reply here. There we go. And we need to clone this. So that way that gets passed into, because this is a different thread. Remember, this is a different thread. The mod view is fancy. It is pretty fancy over there, isn't it? Much better, much better. Umar, how do you know you actually love coding and not going with the trend? Sorry if it's a silly question. If you get like bursts of joy when you see things like this, right here. This is what gives me joy when I see this right here. I'm like, ooh, look at this. It's amazing. Look, oh, it's just so satisfying. Then you like coding. Though not everyone's like that. You can like coding for other reasons. Sokolovi, you tried to learn Python for machine learning, but it's honestly painfully slow. It is, yeah. Machine learning. Hey, you guys. Let's go to our coding and let's finish our cache system here. I believe this should compile now. Maybe. We're going to find out. The compiler is going to say, nope, you can't do it. Oh, we did it. Look at that. that right there. We had it done this whole time. We just implemented a highly scalable, production-ready, memory-safe, parallel multi-threaded cache engine in just a few lines of code in Rust. 64 lines of code. Top to bottom, right there. Look at that, you guys. Look at that right there. We did it. The best part of your day, you guys. The best part of your day. We just did it. I didn't even realize it. I was like, oh, we got to do a whole bunch of other things. Oh, look, it worked right there. See? We just read, we wrote to the cache, and we read from the cache. Implement the delete. We need a string. All right, let's do it. Let's do the last to-do. The best part of your day. Isn't this great? Did you know that you could do this with Rust enums? Bet you didn't know. I bet you didn't know. So now we need to implement a delete here. And we're going to call this delete. We don't need a value. We need to, I think it might be called delete. It might be called remove. We'll find out. We'll find out. You are Jewish. Bonzupi is Jewish, you guys. Okay, so we did remove. Is it going to build? Okay. Oh, we got to add % on that. Get the reference. Cargo build. All right. Looking good. So now that we've implemented it here, we need to do that over here. I'm going to clean that up a smidge. And then I need to send a delete. We just need the key. And we need to send a request that is a delete with just the key. That'll do it. Here, I'm gonna clean this up. There we go. So there's our delete method that's being implemented for our cache selector. We need to then call it. So we can do a delete. So let's do a set here. Let's do another set. We'll call, we'll say, Rust for Kids. Hey, I know. Bill Nye the Science Guy. The software engineer guy. Yeah, Bill Nye the software engineer guy. I like it. I grew up with Bill Nye on PBS. That's where I'm at. Bill Nye the Science Guy. Nice. Me too. Nice. Yeah, PBS. I like that PBS stuff. All right, so let's set a new, so what we're gonna do is here, we're gonna set a new one. We're gonna set delete me. We'll do another delete me. Okay. And then we're gonna do another, grab some value. The key will also be delete me. We're gonna print the delete me. And this will be value.